Unit 2, Lesson 3, Solving Quadratics. I can solve a quadratic with complex roots and relate solutions to graphs. When you have a quadratic with imaginary roots, you will not be able to use the zero product rule to find solutions. You need to use the quadratic formula. Basically, what's happening when you have something with imaginary roots is you aren't going to be able to find nice numbers to make it work. So when you have to do this, you want to set the equation equal to 0, determine a, b, and c, plug into your quadratic formula, then simplify. So solve the following for x. For example, if you tried to find factors of 29 that added to -4, you're not going to be able to do it. It won't work. That's why you have to use your quadratic formula. Now, luckily, this one's already set equal to 0 for us, so we can start by determining a, b, and c. Remember, a is your number in front of your squared term. In this case, we just have x squared, so the number in front is 1. b is the number in front of your variable, which in this case is -4, and c is your plain number, which is 29. Now I can go ahead and plug into my quadratic formula. So I have x equals negative, and I do need that negative from the formula. Then I'll plug in my b value, -4, plus or minus the square root of b squared minus 4 times a times c. It is really important that you plug in numbers in parentheses as well. All over 2 times a. Now you can go ahead and simplify. So -4 gives me a 4. Plus or minus, put everything underneath your square root in your calculator. Do not include the square root, just everything underneath. And you will get -100. All over 2 times 1, which is 2. Now, the next thing you would normally do is put square root of -100 in your calculator. But if you do that, you would actually get an error. You cannot do negative square roots. Remember, negative square roots give you I. So what you can do is have your x equals 4 plus or minus. It'll still be over 2. Take the negative out, and remember, that negative gives you an I. Then put the square root of 100 into your calculator. So take out the negative, you've already dealt with that with the I. Square root of 100 gives you 10. That works out well. You just have to remember to put your I there for the negative. Now what I want you to do is look and see the two numbers, are they divisible by 2? If they are both divisible by 2, you can actually go right ahead and divide them by 2 and simplify even more. You cannot combine the 4 and the 10i because one has an I, the other doesn't. This is the last thing you could do to simplify. 4 and 10 are divisible by 2, so I can go ahead and do that. 4 divided by 2 is 2. Still have my plus or minus. 10 divided by 2 is 5. And you need to keep your I. You can divide it up into two different ones. So you can have x equals 2 plus 5i and x equals 2 minus 5i. That will work. Now I want you to go ahead and take your function, so the original function we're working with, and put it in your calculator. See what it gives you. Take a look at the graph and see where it crosses the x-axis. You should notice this function does not cross the x-axis. This is because you have i's, or imaginary roots. Anytime you have i's, your function will not cross the x-axis. That's why the roots are imaginary. They don't actually produce a root or an x-intercept. Now let's take a look at the next one. X squared minus 5x plus 30 equals 7x minus 10. This one isn't set equal to 0, so I'm going to do that first. I am going to subtract 7x from both sides, and I'll make sure I do it from like terms. So I have x squared minus 12x plus 30 equals negative 10. And then I will add 10 to both sides, still using those like terms. And I have x squared minus 12x plus 40 equals 0. Now that I'm set equal to 0, I can go ahead and identify a, b, and c. A is my number in front of x squared, or 1. B is my plane number, my number in front of x, which is negative 12. And c is my plane number, or 40. Now I can go ahead and plug into my quadratic formula. So I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I'll go ahead and simplify just like last time. Negative 12 gives me a 12 plus or minus the square root of negative 16 over 2. Now remember, square root of negative 16, if you plug that into your calculator, you are going to get an error. So this is where we keep the 12 plus or minus, and we keep the over 2. That negative 16 is the pesky one we have to deal with. That negative can become an I, remember. Then you can just plug square root of 16 in your calculator, and you will get a 4. Now again, take a look and see, are both those numbers divisible by our denominator? And they are. So I'm actually going to do that division. 12 divided by 2 gives me 6. Plus or minus 4 divided by 2 gives me 2. And I have my I. So my roots are 6 plus 2i and 6 minus 2i. Remember, you can't combine those because one has an I and the other doesn't. Now go ahead and graph your function in your calculator. You're going to want to use the one set equal to 0. We always graph set equal to 0. And you should notice, again, it does not cross the x-axis. And that, again, is because we have i's in our roots. Anytime you have an I, your function will not cross the x-axis. Your roots are imaginary.